Welcome. In this video, I want to walk you through an investment opportunity that's emerging almost entirely from geopolitics. For decades, China was known as the factory of the world, a country that exported deflation, flooding global markets with cheap materials that everyone was happy to buy. That arrangement worked well for a very long time. But over the last few years, that story has started to turn, and understanding exactly how it's turning is where the investment opportunity lies. Let's dig in. Before we get into the opportunity, I want to be upfront about the risks, because this thesis can turn against us just as fast as it turned in our favor. 4 things worth watching. First, the US is sitting on a heavy debt load, and any sustained inflation pushes up the interest burden on that debt, which pressures the entire financial system. Second, everything in this presentation assumes the world keeps diversifying away from China, but at some point Washington may decide China is simply too central to keeping inflation under control, and reach some kind of accommodation with Beijing that slows this whole trend down. Remember, China+1 does not mean China minus China. Third, China didn't build its industrial base overnight, it took 3 decades, and no amount of capital replaces that kind of head start quickly. And fourth, the ongoing Iran-linked crisis in West Asia could tip the world into a longer economic slowdown. After the strong post-COVID rally, a correction was arguably overdue anyway. Keep these 4 in mind as we go. So what actually gives China this advantage? It comes down to 2 very different things. One is pure geology, an accident of what's sitting in Chinese soil, and the other is a deliberate industrial strategy built over decades. Take gallium. China controls about 98% of primary production, and it's critical for 5G and 6G infrastructure, EV charging, and military radar. For heavy rare earths, China controls roughly 75% of mining and 94% of magnet production. That's the natural resource side of the moat. Now look at lithium. China doesn't actually dominate the mining. Australia, Chile, and Argentina dig up most of the raw ore. But nearly all of it gets shipped to China for refining, so China still ends up controlling about 70% of battery-grade lithium chemical production. It's the same story with gallium and germanium refining. The raw material is available globally, but the refining capacity sits overwhelmingly in China. That's the industrial half of the moat. To make sense of all this, I think of China's advantage in 3 buckets: true geological monopolies, geological plus refining hybrids, and pure industrial or processing capacity. And there's a real reason the world let this happen. Building a chemical or metals refinery in the US, Europe, or India means fighting through heavy regulation, local environmental opposition, and strict toxic waste rules. Western countries wanted the high-tech end products, but not the dirty processing behind them, so in effect they exported the pollution. China, prioritizing rapid industrial growth, welcomed that processing into dedicated industrial zones with loose early-stage environmental enforcement. Beijing also didn't treat refining as a standalone profit center. It subsidized it heavily, with free land, cheap state-backed loans, and subsidized coal power, keeping global prices of refined materials artificially low for decades. That made it commercially impossible for Western competitors to survive, and it's exactly what drove refiners like America's Mountain Pass rare earth facility and Germany's AOS Alumina out of business, cementing China's monopoly. Heavy rare earths are close to a complete Chinese monopoly. The ore itself sits mainly in Chinese soil, so the rest of the world doesn't just need to discover new deposits, it needs to build an entirely new refining capability from scratch. That's what makes this the hardest moat of the 3 to break. This second case is more solvable. Here, the ore is scattered across the globe, but China simply built out more refining capacity than anyone else, while Western refiners shut theirs down as unprofitable. The fix is conceptually straightforward: build refining and processing capacity outside China. And it's already happening. Tech Resources in Canada and Umicore in Belgium are scaling up, and the US has put over $30 billion behind domestic and allied processing since the 2023 to 2026 export controls. The third case is different again. Here, the rest of the world has the same natural access to the raw inputs that China does, but China is the one that actually built the processing capacity over decades, largely by being willing to accept the pollution that came with it. So what actually triggered this whole China+1 movement? 3 things, really. First, China itself started recognizing the environmental cost of this industry and began tightening enforcement. Second, as the country got wealthier, its own citizens started demanding better living conditions, and then COVID hit, and entire industrial regions were locked down to stop the spread. That's when the rest of the world got its first real taste of what supply chain concentration risk actually feels like. And third, China has simply grown into a country the US can no longer dominate the way it once could, and that loss of leverage is uncomfortable for Washington. Here's the important part for us as investors. What China built is enormous, but India doesn't need to replicate all of it. Even capturing a fraction of that industrial base is enough to make a number of Indian companies highly profitable. That's really where this entire investment thesis lives. As the world started hunting for alternatives to China, a set of these stories began to emerge, and Laurus Labs is one of the clearest. Interestingly, some pure chemical players were already benefiting from this even before 2020, back when China first started cracking down on its own polluting industries, which pushed Chinese costs up and made outside competitors price competitive again. Then Laurus got a very specific opportunity around the COVID years, supplying COVID-related APIs, including Paxlovid-linked work. That revenue eventually evaporated as COVID demand faded. But here's the key point. What didn't evaporate was the confidence, the customer relationships, and the capital that windfall generated. Laurus took that and reinvested it into backward integration, building the in-house chemistry that makes it structurally more competitive today, long after the COVID story ended. Company results start showing the improvement, and so is the stock price. The market has started to recognize this shift. Take a look at how the stock has moved as this transformation has played out. Now let's look behind the scenes at what's actually driving this. The West, mainly the US and Europe, is pushing hard for diversification away from China. New laws are being introduced, and companies are having to adapt, even though building a new supply chain realistically takes several years. That's opening real doors for Indian companies. Requests for proposals have started flowing in, and partnerships, technology transfers, investment, and capital expenditure are all rising. The impact is still building, but it's becoming visible. Let's get specific about the three chemical moats China holds over Indian pharma. The first is fermentation. Making complex organic molecules requires growing microbes in massive, temperature-controlled vats over weeks, and that's an intensely power-hungry process. China built state-subsidized fermentation clusters in its northern provinces where industrial power is cheap. India doesn't have that same ultra-cheap, continuous power grid, which makes Indian fermentation intermediates more expensive to produce. The second is hazardous core chemistry, fluorination, which underpins statins, blood pressure drugs, and antidepressants. China controls the upstream fluorspar supply chain, and its industrial zones are built to handle toxic synthesis at a scale that's difficult to clear quickly under Indian environmental rules given proximity to local populations. Here's the number that tells the story. Historically, Laurus relied on China for about 2/3 of its raw inputs. Through aggressive backward integration, literally building the intermediate chemistry in-house, the company brought that direct Chinese exposure down to roughly a third. But look one layer deeper, and the raw atomic feeds behind even those in-house intermediates often still trace back to Chinese suppliers. That's the macro to micro takeaway. The headline number improves faster than the underlying dependency actually does.
While a company like Neuland or Laurus creates the final API in an Indian facility, roughly 70% to 75% of the underlying chemical intermediates and KSMs used to build those APIs were imported directly from China. In the case of Laurus, the company is a global giant in supplying active pharmaceutical ingredients for HIV treatments like tenofovir, lamivudine, and dolutegravir. To synthesize lamivudine, a core key starting material known as cytosine is required. China operates an infrastructure monopoly on the commercial synthesis of cytosine. Similarly, the production of tenofovir requires adenine, which is primarily derived via massive-scale chemical synthesis in Chinese chemical hubs. Because ARV tenders operate on fixed-price global procurement contracts, even a minor change in these raw chemical prices directly compresses Laurus's gross margins. Innovators request specific novel chemical entities. To construct these custom molecules, Laurus requires specialized catalysts and high-purity industrial solvents. Even if Laurus designs a completely non-China synthesis pathway for the core molecule, the auxiliary chemical reagents and baseline solvents are mass commercially produced in China. A logjam at Chinese shipping ports can delay a clinical batch validation, impacting project execution timelines. Laurus has deployed a massive 3,000 crore capital expenditure program to build deep backward integration facilities in India, aiming to synthesize their own KSMs in-house. However, their raw chemical feeds still trace back to Chinese-based supplies. Now take the case of palladium. Over 80% of the world's raw platinum and palladium is mined in just two countries, South Africa and Russia. China produces less than 1.5% of the world's raw mining output for these metals.
Chinese chemical companies buy raw platinum and palladium from South Africa, process it through advanced organometallic labs, and turn it into custom, cheap high-purity catalysts. For high-purity validated clinical trials, Laurus bypasses Chinese chemical processing by buying its precious metal catalysts from top-tier Western specialists like Johnson Matthey, Heraeus, or Umicore. These companies source their raw metals straight from South African mines and refine them in European facilities. Laurus does not throw them away after a chemical reaction. They operate advanced internal precious metal reclamation loops. After an API batch is synthesized, the spent palladium is captured from the liquid waste, purified in-house, and recycled back into the next manufacturing run, reducing their reliance on fresh chemical shipments. To manufacture the organic linkers, like sophisticated phosphine ligands, that are bonded to that palladium, Western refiners often buy basic raw chemical precursors from China. To bypass China's dominance over the baseline organic molecules attached to precious metals, Laurus is scaling its internal capabilities through a combination of heavy capital deployment, process innovation, and corporate restructuring. Laurus consolidated SRIAM Labs into a pure-play, specialized intermediate and key starting material powerhouse. By freeing up these specific reactor blocks from standard generic production, Laurus created dedicated manufacturing space focused exclusively on synthesizing complex organic building blocks, including the advanced phosphine ligands required by their CDMO synthesis teams. In addition, Laurus successfully replaced dangerous pyrophoric reagents with less hazardous combinations like sodium hydride and zinc chloride. This process innovation allows them to manufacture high-complexity organic links right inside India safely, bypassing the tight environmental and regulatory bottlenecks that usually stall Indian chemical plants. Now Laurus is addressing palladium bonding requirement in 2 stages, first in coordination with Europe and then fully in-house. Stage 1. SRIAM Labs, the specialized intermediate arm of Laurus Labs, and European mega-refiners like Heraeus Germany or Johnson Matthey UK operate as independent cogs that meet right at the finish line. In Europe, the European refiner buys raw, pure palladium metal directly from South African or Canadian mines, bypassing China. In India, SRIAM Labs manufactures the highly complex organic ligands, starting from basic hydrocarbons inside their newly restructured Indian reactor blocks. The assembly. SRIAM Labs ships their finished ligands directly to the European refiner's high-tech organometallic labs. The European refiner chemically bonds their pure palladium atoms to SRIAM's Indian-made ligands. The refiner then packages this final premium high-purity catalyst block and ships it back to Laurus Labs' CDMO synthesis facilities in Vizag to run global oncology or biotech clinical trials. Next stage. The ultimate goal of Laurus's massive additional 2,000 crore capital expenditure push is to eliminate the need to ship anything to Europe for assembly. Laurus is actively building the capability to execute the final precious metal bonding in-house within India. The local loop. Under this model, Laurus buys basic, unrefined palladium or platinum salts globally. The integration. SRIAM Labs feeds its domestically synthesized ligands directly into Laurus's own chemical bonding labs. The result. They stitch the metal and the ligand together in India, achieving 100% self-reliance for that specific catalyst line.
And Pharma isn't just a Laurus story. The same playbook is running in parallel across India's other major CDMOs, each pushed by China+1 demand. For example, Divi's Laboratories. To scale its high-margin GLP-1, obesity and diabetes, custom synthesis and peptide division, Divi's Laboratories is implementing a hyper-aggressive backward integration strategy at its freshly commissioned Unit 3 facility in Kakinada, Andhra Pradesh. Shilpa Medicare. Following intense research and development, R&D investments over the last decade, Shilpa Medicare is beginning to reap operating leverage benefits.
Now let's flip the picture and look at a sector where the moat actually runs the other way. Semiconductors are roughly 10% geological or chemical, and about 90% human-made, and that 90% sits with the US, the Netherlands, and Taiwan, not China. That reversal is exactly why Beijing leans so hard on rare earths and gallium. It's one of the few real levers it has left in this fight. India itself is a massive market, and it's now entering this industry too, with a 2-track strategy: front-end wafer fabrication, and back-end assembly, packaging, and testing. The semiconductor industry doesn't run without a specialty chemicals base underneath it, and India's chemical industry is stepping up to supply exactly that layer, supporting the broader semiconductor build-out. It's worth remembering the order in which all of this unfolded. Chemicals moved first, and pharma followed close behind, and that head start is exactly why pharma is further along than every other sectors. Let's look at clean energy and EV. Sona BLW is India's largest importer of rare earth magnets, which makes it the auto component company most directly exposed to this entire framework. In April 2025, China restricted rare earth magnet exports, and Sona, which was importing over 120 metric tons a year for Tesla and Stellantis EV motors, saw its production disrupted almost immediately. The response has been fast. By October 2025, the company had validated a rare earth-free ferrite motor that de-risks about 95% of its core motor portfolio. It's partnered on next-generation magnetless motor technology, and it's now building domestic rare earth magnet manufacturing backed by India's Auto PLI scheme. It's also worth watching the downstream side. Aether Energy's electric scooters are heavy consumers of the same chips and magnets, exposed to the same shock just one step further down the value chain. Let's take a high-level look at Sterlite Technologies. It's really a data center infrastructure story more than a pure fiber optics story. Optical fiber and connectivity are just the current revenue line for a much bigger hyperscale and AI data center build-out. Sterlite has already onshored final assembly to the US and built closed-loop helium recycling into its manufacturing. What it hasn't solved yet is the upstream piece. Both Sterlite and HFCL still depend on foreign refineries for the germanium-bearing gas that goes into fiber, since neither company runs its own smelting.
The wrong question to ask is simply, which company will benefit from China+1? Almost every name in this space can make that claim. These 6 questions are what actually separate a real durable opportunity from a company just riding the theme. Is the company actually gaining business because customers are diversifying from China? Is the opportunity temporary or structural? Does it have a technological or manufacturing moat? Are global customers increasing dependence over time? Is management investing ahead of demand? What happens if geopolitical tensions ease? In short, the goal isn't to predict geopolitics, it's to find companies that monetize the shift and survive after the excitement fades. Laurus Labs is several years into converting this exact alignment into hard, measurable margin, which makes it the clearest available template for what a fully executed version of this thesis actually looks like. Sona BLW, Sterlite, HFCL, and India's emerging semiconductor players are trying the same theme in their own sectors. To close, here's where I'm personally putting my attention. The market has already started re-rating Laurus. That move is underway. Beyond Laurus, Jubilant Ingrevia, Kiri Industries, and Supriya Lifescience are the other names I'm watching closely as this theme develops. As always, treat this as a starting point for your own research, not a recommendation. All the data here is from public sources and needs revalidated before you act on any of it.